All right, so I'm just going to take a minute to run down the objective 2.3 and do a recap of it. First thing that you're looking at is you're looking at the spectra of all the elements. And the big thing here is if you look at every single element on the periodic table, no two elements have the same spectra. And that is because no two elements have the same number of protons. And the protons affect the number of electrons in a neutral atom, which affects a lot of your physical and chemical properties. So you will not have to identify any spectras on this assessment or any assessments for that matter in this class. Also, you would never have to be able to memorize any of these spectras. Okay, that's something above and beyond. Just knowing that they're all different because of the protons is a big deal here. Now, you do need to know how we get the spectra and we get the results from the flame test. So what happens is we first have to give electrons energy, and we did this in our flame test by providing a flame, and the energy that we provided was heat energy. So the electrons absorb the heat that you see on the left, and they currently are in the unexcited state, okay? Until they actually absorb the energy, then they move to the excited state. So the analogy that I gave you is in order to get you to an excited state, you have to drink a ton of soda, eat candy, or I give you $1 million, okay? You get it really excited. Now, just like the electrons, you can't stay at that excited state for a long time. So if you have a sugar high, you're going to drop. You're going to get unexcited. You're going to crash sometime. And that's what the electrons do. So if they're at their excited state, they've moved away from the nucleus, they're going to have to drop towards the nucleus once again because they're going to release that energy and get back to the unexcited because they just can't maintain that. And when they do and they release that energy, it's in the form of light energy. And that's when we see the flame test results. Now, based on the element, it takes some elements more energy to get excited as other elements, just like students. It takes some of you, me bribing you $1 million for you to get excited, or it might take you just a lollipop, okay? And that's the same thing with elements. And based on the amount of energy that is needed to get them excited, gives us the different colors and gives us the different brightness and all that kind of stuff. So that's why we have differing amounts of light and the color that we see. So yes, this goes back to electrons, but again, without my protons determining electrons, we wouldn't have these defining properties. Okay, so you will need to know this idea of how it releases light for that objective as well. Now, the results that we see are from the flame test. So that's what we see here on the right. We actually see the light, whether it's green, blue, purple, what have you. But if we were to dissect that light into the different bands of energy and color, we would then get the spectra. Now, we don't have that capability in class, but if we did, we could take this color and we could break it down. And pretty much what this is just the recipe of that color. So what bands create that we see, okay? This is, again, something that you will not need to memorize. The big thing is that all the spectras are different because all the amounts of energy needed to excite the electrons are different because the protons are different. So again, always goes back to the protons. Things that you would need to know, no two elements are the same. Every element has a unique set of properties, whether they're chemical and physical. And you should have seen that with your activity. You should have seen that for all 6 elements that I made you do, not one was exactly the same as another. And that goes always back to the protons. You don't have the same element if you have different protons, therefore you don't have the same properties. Other things that would be important to know, the flame test is one way for us to see or get the spectras. Spectra is a chemical property because there's a change in the electrons, which means there's a change in the chemical makeup. The physical property that could be something that we could use is density. Remember when we went back to our unknown metals, and if we looked at the unknown metals, every unknown element has a specific density, or every element has a specific density. And we can use that density or the spectras to find unknown elements. So that's what they use them for. Spectras are like fingerprints, again, using to identify. So no two fingerprints are the same. Same thing with a spectra. And no two elements are the same because of the protons. Again, always goes back to the protons, the most defining subatomic particle, which affects a lot of stuff. And again, yes, we have the flame test results because of electrons, but without protons determining the number of electrons, we then wouldn't have these defining properties. So these are all of the stuff that you need to know. Make sure your activity for 2.3, the unique atom, is completed. If it is not completed in its entirety, you will not be able to take the assessment. So please make sure that is completed as well. Let me know if you have any questions. Good luck.